Yep. Let's close all of these because we don't need those. Because this is structures, this isn't statics. Okay. All right. You all ready to talk about your first celebration, hopefully? Okay. So first celebration is going to be on Friday. Attendance grades are up to date. You all turned in homework 4 today. I'm going to post the solution to homework 4 later on today so that you have it. But all of the other solutions should be available, and all of the other homework assignments that are other than homework 4, since you literally just submitted it, are all graded. So grades are up to date. In terms of the grade structure, because I always usually get asked, usually on exam review day, I'll put this right here so that you know how the grade is broken down. Won't really matter now so much, but if you had me for statics last fall, you know that near the end of the semester I posted that at-home game where it was the spreadsheet to where you could put in your grades and you could back calculate what you needed to get on the final to get an A or a B or a C. My buddy in grad school, he called that playing the at-home game, so that's why I called it the at-home game spreadsheet. So I'll do that like November-ish or something because I know everybody will be interested in that. Okay, let's talk about exam 1 because I want to make sure that everybody here is aware of how the exam is going to be administered, and we'll see if there's any technical hiccups or questions or so on and so forth. But let's go through the motions here. Okay, so we're first going to talk about logistics, then we'll talk about what's on the exam. Logistics. Okay, so I'm going to do the same thing with you all that I'm doing with statics. So the exam is supposed to be from 10 to 10:50. What I'm going to do is it's going to be an exam that's delivered on Blackboard, and I'm going to open it a couple minutes early. Instead of opening it like right at 10, I'm going to open it at like 9:58, and I'm doing that so that we can all be in here, and if there's any, Blackboard's crashing on me, that I can start it and restart it so that you all have a little bit of time. And instead of closing it at 10:50, I'm going to close it at 10:55. Again, those are some buffers that are put in place just to make sure that if there's any Blackboard issues and whatnot, that we can work through that. It's designed to be 50 minutes long, and what I mean by that is, if you had me for statics, I mentioned this in there. I do the same thing in there that I do in all my classes, is I tend to employ a rule of 3, and what I mean by that is I will say, let's just keep the math simple because it's not going to come out evenly, but let's say the exam is designed to be 60 minutes long. If it's designed to be 60 minutes long, then I should be able to do it in 20 minutes, right? So I actually make the exam and do the exam. And if I can do it in 20 minutes, then you should be able to do it in 60. And it's never given me any problems in the past in terms of building a time crunch exam. When I developed my teaching philosophy, what I did is I collected a list of all the stuff that professors used to do when I was in college that annoyed the hell out of me, and I said, I'm not going to do that. And one of the things that annoyed the hell out of me is a professor that gave me an exam that took 4 hours to do and only gave me 50 minutes. I'm not doing that to you, okay? That philosophy's always seemed to work with me. I will provide a set of like blank pages and whatnot, and so that you all will have scratch paper to work on. And so you turn that in after the exam. Show as much work as you can because I am a partial credit guy. But if you do the whole problem in your head and you just write x equals 2, and that's wrong and there's no work to show for it, I don't know what I can do in terms of partial credit. So make sure that you show as much work as you can. The exam is so in terms of how it'll operate on Blackboard, it is a forced completion exam. So what that means is once you start it, it has to be completed in one sitting. And if for some reason you have an issue like Blackboard craps out on you and whatnot, I can restart the exam because I'll be here for you. Because that's not what I'm trying to do. I'm not trying to get in your way in terms of Blackboard being mean to you. Like we'll fix that. It is timed. I have the time limit set at 60 minutes, and it's set to auto-submit. That is for your benefit. That's not as a punishment, because the idea is that if you forget to save and submit, it'll do it for you. So that's for you. That's not as a punishment. I have it set to where the questions will appear all at once. so you can scroll up and down throughout the whole test, and after you finish it, you can check and make sure if your answers are right, and so on and so forth. Again, that's for your benefit. That's not to get in your way. As for approved materials, look, y'all are engineers, or planning to be engineers. When you're out, and if you're in the office and you're designing a bridge, nobody's going to lock you in the cubicle and say, you know, here's a pencil and a slide rule, figure it out. I don't have a problem with that. But let me also say this: I don't think that notes are really going to help on this exam. Like, what are the formulas? Sum of forces and sum of moments. There's your formula sheet. You know what I mean? There's not a lot to it. You know, when you if you all decide to take me for steel design, I'm curious how many of you are interested in taking steel design. Okay, cool. If you decide to take steel design, okay, that's different. There are a lot of formulas and a lot of equations. There's a lot of expressions, and a formula sheet really would help. I'm not saying you can't build a formula sheet. I don't care if you build one or not. It just, I don't think it would help. Not like it would in some of your later courses. But it is open book and open notes. I'm going to leave all the notes on Blackboard. You can use any resource on Blackboard you want. I don't care. You can use the lecture notes. You can use the OneNote. I don't care. I don't have a problem with that. The one thing you can't use is another person, okay? So that means, you know, messaging somebody in here. That means Chegg. You know, Chegg didn't just miracle itself onto the internet. You know, somebody put it there. You know, so that's another person. But again, I don't really think it would be necessary with the way this stuff works. I mean, and I actually think that stuff would get more in your way that if you just did the problem, you'd do fine. As for what's going to be on the exam, there will be 4 to 5 conceptual questions, so like short answer questions, 3 computational problems. And you can probably guess what the 3 computational problems are based on the topics that we've done in here. But do me a favor, and on Blackboard, type out an answer for every question, even the computational ones. I'm not saying you need to use that fancy formula builder in Blackboard to type out the answer. You can just say, like, reactions, AY equals 12 kips or whatever. Just something simple, because it makes grading it a lot easier. So this weekend, I'm going to have 87 exams to grade. 88 exams to grade, because I'm giving the statics exam today. That was really stupid on my part. but there were reasons for the way the classes were set up. But the point is, like, if I can pull up problem 1 and see what everybody wrote on problem 1, I can go yes, 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 no, yes, no, yes, no, and do it really fast and get the grades done quickly. So it really helps me out on grading if you type out an answer for every question. Still show the work and show the answer on your work, but if you can type it out, it really would help. All right, any questions on the format? Because I'll talk about what's on the exam here in a second. All right, here's the topics on the exam, and if you wanted a hey, here it is on the exam, this is it, okay? So stability and determinacy. Make sure that you can classify a structure as unstable, statically determinate, or statically indeterminate, and if it is indeterminate, specify the degree of indeterminacy. For support reactions, make sure that you can compute support reactions on statically determinate structures. I'm not going to tell you to analyze an unstable structure, and I'm not going to tell you to analyze an indeterminate structure. There's no point in analyzing an unstable structure because it's unstable, and you can't analyze an indeterminate structure yet because we haven't finished out determinate structural analysis. Although I could show you the sort of, you know, first level concepts on how you would analyze. Like, let's say you had a truss and the truss had one too many supports, so it's indeterminate, right? So one of the ways that you can analyze an indeterminate truss is you take a look at one of those supports, and if you've got a support, what's the deflection at that support? 0, right? So what you do is you remove the support, you let it deflect and compute the deflection, and then you ask, well, how much, let's say it deflects 2 inches downward, well, what upward force is required to push it 2 inches upward? That's the reaction. So that's indeterminate analysis. You can't do indeterminate analysis without understanding forces and deflections. So you don't have to do that on the exam. I'm just, you know, I'm an educator. I can't help it. Okay, so in terms of support reactions, make sure that you can handle concentrated forces, concentrated moments, make sure that you can handle distributed loads, make sure you can handle fixed supports, pin supports, roller supports, internal hinges, everything we've done with reactions. For trusses, method of joints, method of sections, And for deflections, make sure you can analyze real and virtual structures and compute the associated deflections. The rest of these slides, if each one of these lectures have been one of Dr. Mike's albums for the past week, these are the greatest hits. So what I did is here's the greatest hits from the past few lectures. So this is the degree of external indeterminacy. So the IE, you compute that as taking the unknowns minus the knowns. So the unknown reactions minus your 3 equations of equilibrium plus any equations of condition. And remember, if you have a negative value, it's unstable. If you have a non-negative value, it should be stable. Remember, should be means the reactions can't all be concurrent, they can't all be parallel. But whatever your I value is, if it's positive, if you have an I value of 4, it's statically indeterminate to the 4th degree. So don't forget that. That's IE. This is IT, the internal indeterminacy of a truss. Bless you. So the internal indeterminacy of a truss is computed by taking the unknowns, M plus R, minus 2J. Okay? 2J is the knowns because for every joint there's 2 equations of equilibrium, and the unknowns in a truss are the support reactions, and there's 1 unknown for every member because that's the axial force inside that member. Same deal. If you have a non-negative value of I, it should be stable. What do I mean on should be? Well, the truss has to be externally stable for it to be internally stable, and the truss has to be constrained against rigid body movements. I'm not going to get all weird with you on that on the exam, but basically if you have a truss and there's like a region with no triangles, it's probably unstable. Supports and loading types. So we've got our hinge or pin support, roller support, fixed support. Make sure you know the 3 reactions associated with those. And here are our idealizations of distributed load. So a uniformly distributed load, we collapse like this. A triangular distributed load, we collapse like this. Which, by the way, all these slides and whatnot are on Blackboard. So there's not anything here that isn't on Blackboard. Incline loads, make sure that you can handle taking an incline load and splitting it into its x and y components, either with the slope ratios or trig functions. I don't care whichever you're comfortable with. I do think there is an efficiency that if you are given the slope ratio, to just use it as opposed to trying to use inverse tangents to come up with an angle and then sines and cosines of that angle. But if that's what you're comfortable with and that gives you the right answer, I'm not going to micromanage you. So whatever you think is appropriate. Inclined rollers, make sure that you know how to take that inclined roller and determine the x and y components of that reaction correctly. We talked about that, so I'm not going to belabor that in here. Cutting sections through members and hinges. So if you cut it through a member, you have at most 3 unknown components. If you cut it through a hinge, you have 2 unknown components because you know inside the hinge the internal moments are 0. If you cut a section through a truss member, there's only 1 internal force, and that's the axial force because truss members either experience tension or compression, or 0, but it's only axial force effects. The method of joints, when we utilize the method of joints, we solve joints with at most 2 unknown members because we only have 2 equations of equilibrium that we can utilize at a joint. Method of sections, we can cut a section through 3 unknown members. Because we're dealing with a non-concurrent force system, when we look at method of sections, we can utilize that 3rd equation of equilibrium. I went ahead and put the 3 rules for 0 force members in here. So here's the 3 rules. No load applied at the joint. If you got 2 members with unknown forces and there's no load at the joint, and there's nothing else going on, those are 0 force members. The 2 members with collinear loads, if you have a load that's collinear with one of the members, the other member is a 0 force member. And then if you have 3 members and 2 of them are collinear and there's no load at the joint, then the other member is a 0 force member. I just throw that on you if there's something that can make your life a little easier when solving the trusses that present themselves on the exam. And finally, virtual work for truss displacements. We need 5 terms for each member. The geometric properties, or the material and geometric properties, which are the length of the member, the E value of the member, and A value of the member. Remember, the length, in terms of USCS units, needs to be in inches, so don't forget that. And then from our analysis, if we're solving for a given displacement, We need two values from analyses, one from the real structure, the actual loads that are on the truss, and then the virtual structure, where we take all those loads off and we just put a single load on the truss at the point of interest with a magnitude of 1 in the direction of the assumed displacement. And if we get a negative answer, that just means the deflection is in the opposite direction. Yes, sir?
Are we allowed to use Excel?
Are you allowed to use Excel? That's a good question. You know what? Why not? I don't care. But I will also tell you something else. If I give you a truss displacement problem, I'm not going to give you a truss displacement problem with 857 members in the truss. Not doing that, because you don't have time to do it. So the truss deflection problem will be manageable, okay? If you are going to do Excel, send me the Excel file, and it better be an original file, no using of other stuff. So, but I don't have a problem with that. I actually don't. I'll tell you, when we do beams and frames, there will be, I will go ahead and tell you there'll be some calculus in there, but the calculus you'll be able to do on your calculator. Like, it won't be, it'll be numerical, like definite integration, so you can just plug and chug. I'm going to stop. Floor is yours. We already have one question. Whatever you want to ask. And just so you're aware, I've done exam review sessions that have gone all the 50 minutes, and then I've had some that are like, fam, we're good, we're leaving. You know, that's fine too. I'm a dork, I know, it's okay. I'm such a dork, I know. Ask my wife, she'll tell you how much of a dork I am, you know. Yes, well, you, then you.
Okay. I'm gonna look. Okay, so with the zero force members, with the three rolls that go into them, it's like two collinear. I'm not sure I really understand that.
So, okay, all right. So what's going on there? Okay, so what's going on here with the first rule is just if you have a joint out in space and there's no loads on it and there's only two members that are unknown, there's zero. That's easy, okay? And here's the reason why. Let's just take a look at this joint, okay? Let's imagine we were doing a problem and this was the joint. So here's the joint, no external loads, a horizontal member and a diagonal member, right? So if I sum forces in the vertical direction, this has an x and y component, the vertical component is 0. And if the vertical component is 0, the horizontal component is 0. So that's 0. And if I sum forces in the horizontal, all I've got is that. So this is 0. So that's why this works. With me so far? Now let's take a look at the next rule. Okay, and in order to explain the next rule, I want to look at this one. So here's a roller. You've had problems like this. I know you have. We've done them on homework assignments. Sorry about that. We've done them on homework assignments, right? So here's a roller. Here's a reaction. If I sum forces in the x direction, if I've got, 50 kips going this way, that's got to be 50 kips going that way. But then when I sum forces in the y direction, there's nothing here. It's the same thing, right? If you look at this, right? Sum forces in the vertical direction, x and y component, there's nothing here. So that's 0. So this is a 0 force member, but I mean, that doesn't mean this one isn't. 20 kips to the right, 20 kips to the left. That's what's going on there. It's just, all it's doing is taking equilibrium on a joint by joint comparison and making conclusions about given scenarios. That's all it is, okay? So if you look at, see, Rule 2 and Rule 3 are really damn similar, because here's Rule 3, and imagine instead of a load, it's just another member, right? Sum of forces in the vertical, 0. And that member equals that member. That's it. And to be clear, this is just a tool that is going to help you solve trusses faster. That's all it is. You don't have to use these tools if you don't want. Like, you can use a screwdriver. Here's an impact driver. So
when you was showing our work, do we do that on the scrap paper?
Yeah.
So if the problem's wrong for the partial credit, you just refer to the scrap?
Yes. Yes. What I would do virtually is, if the exam's from 10 to 11, I would just say upload your scratch work by noon. So, but since we're all in person, you can just give it to me. I'll have a little basket over there, and you can just drop it in.
We don't have to use cam scan or anything like
No. No, you don't have to use cam scanner unless for some reason you have a university excused absence and you weren't going to be able to be here. In that case, I'd have you just scan it and email it to me. So. But yeah, I'm trying to keep it as straightforward as possible. And again, I know if all I was doing was teaching this class, I'd probably just do the exam on paper. But because I've got this and statics, I'm going to have like 90 exams to grade this weekend, and I don't even know if I'll finish them. So it really makes it a lot faster. It really does. So I'll just lock myself in my office and what's that? Well, with only a pencil. Actually, it'll be with a Keurig machine. That's what it'll be with. Yeah, but I normally, when I've taught this class in the past, we don't have our first exam until like late September, early October. So it would be a couple weeks from now. But because I moved trust deflections earlier, I said, let's just do all the trust stuff and get it over with. So there will only be 2 times we revisit trusses in the end. And that's indeterminate analysis, if we have time to do it, in influence lines. And the influence line homework that we do is not only going to be very short, but you'll have software to make your life a little easier. So, which, if you watch that, did you watch the little snippet video I did on the horizontal deflection? If you saw that, there was some software that I showed you. We're going to use that later on in the semester. I'll show you how to use that later. And you'll get a little ticked off at me, and you'll go, how come you didn't show us that earlier? Because I wanted you to learn how to do it first. Dr. Mike's mean. I know, again, I'm a dork. Any other questions? I mean, please, we can talk about whatever. We can go through homework solutions, whatever you want, you know. Don't, just do me a favor. Whenever we end this, don't go, I wish I'd have asked him that. No, ask. I guarantee you that this is a secret from the professor's side of things. I know that there have been times as a student you're like, oh man, I'm afraid of asking that question because I'll look stupid or something, right? You ask that question, I see about 6 or 7 other people are like, yeah, I wanted to ask that question too, but I didn't want to be the person to ask. So yeah, go ahead and ask it. Yes, sir.
Will the solutions be for homework 4 be on before Friday?
Yeah, I'm gonna post them later today. Yeah, I have it done. I just hadn't scanned it yet. So, but yeah, it'll be up before the end of business today.
I was trying to see if I got the question later.
Now, the one thing I'll tell you is that solution is actually kind of short from what I put together, because what I did is I said, here's the real analysis, here's the 2 virtual analyses, here's the answer. So I didn't like go into hyper detail on every single joint, because at this point, hopefully, we've done enough method of joints analyses that you get it. So it wasn't like I needed to go into that detail, but I provided enough to where you could spot check your answers. And so I tend to do that sometimes as we get later on to the topics, like when we do beam deflections, I probably won't go through all the hyper detail of drawing the moment diagrams. I'll just say, here are the functions. And so if you didn't get the same function I did, then you'll know which one was wrong and you can go through it. Because we're going to have oodles of assignments looking at moment diagrams. It's not like you're not going to get practice there. Any other questions? I mean, we can, whatever you want. Are you feeling comfortable about the exam? Feeling like, you know, I'm going to throw all these crazy curveballs at you and I'm going to be mean? And one thing I will tell you, okay? Here's something I'll tell you. I'm not a micromanager on stuff like this, and I mean that globally on just about every topic. Here's an example. I might give you a structure and say, compute the reactions. I don't care how you do it. If you want to draw the little table with the moments going this way and the moments going that way, that's fine. If you want to write out the equation, that's fine too. I'm not going to go, where's those parameters? I'm not doing that. When it comes to truss analyses, I'm not going to tell you whether or not it's a method of joints or method of sections. Do whichever one you want. I'm not going to, I want you to have the freedom to do it the way that you want. Yes?
I remember when in statics that if we got the wrong answer, you would work it out with where we messed up.
Mm-hmm.
That way you got credit.
Yes, and that's typically how I grade. So just to clarify that question, and that particularly works very well in here. I'll tell you that's kind of tough in some of the design courses because they're very open-ended. But what I'll do is this. A good example of what you're talking about is truss deflections. Because what I'll do is I'll have a little spreadsheet template set up to compute the deflection. Let's just say I give you a deflection problem like that. And then you got member AB in the real analysis wrong. So I'll change that value. And if I get the same thing you got, then I know it's just that. And so I'll just take off for that accordingly. I really try and do my best to ensure that whatever that I'm deducting, that it is proportional to the scope of the problem. Okay? If you have a 30-point problem and you missed one part, that's not a 20-point deduction. It's however much that affects the problem. Now, there is something to be said that it goes into the concept, right? Like if you get a value wrong and you get a value wrong, but your mistake meant that there was a conceptual understanding that you failed to grasp. That wasn't his issue. His was just he hit the buttons on the calculator wrong. I might take more off for you than I am for him because it's about learning. But I really pride myself in ensuring that whatever the deduction that I give, it's proportional to the scope of the problem. And another thing is that I don't grade your exam and then your exam and then your exam. I grade problem 1 for everybody. Problem 2 for everybody. First off, it's funny how somebody asks, do you know how I did on the exam? No. I know how problem 6 did. But I do that because as I'm grading 60 statics problems, because I'm looking at problem 6 for everybody, then I'm in the same headspace for every problem. So if there's any common deductions, I'm taking the same off for every student. Remember when I said my teaching philosophy, one of the things that bugged the hell out of me? Well, one of the things that bugged the hell out of me, I have friends who take the same exam I do. They got the same deduction I did, but they got 6 points off and I got 12 points off. Bunch of junk. What happened there? I'd really try and avoid that. I don't like doing that. The downside is I need a lot of coffee because it takes a long time to do it. So, but I think that's the right thing to do, See, I will try and get your exams back on Monday. I will try. If it's a little bit later, I apologize, but I don't like them sitting on my desk very long myself. I guarantee you, as annoyed as you are that you're not getting your exams back, I'm probably just as annoyed myself. So, and in my new position, I certainly have a lot of other stuff to do. It's an interesting job, I'll say that. Any other questions? Please, Going once? Hold on, wait.
Are you going to provide us with your litany for the exam?
My what? No, but all right, hold on. Here's what I will do. Okay? All right, we can vote on this together if you would like, but hold on. We got a serious question we got to ask. I don't know why my caps lock is on. So, let's see. No, let's do the robot race. So we'll do, how many racers? Okay, so I think there's, oh, you gotta be, no.
So You just make like 10 tabs.
So we'll do 6. And then just start. Start. Oh, thank you. I about clicked the ad. Good Lord. So yeah, this is a good thing to know that I need to turn the mute on here. But yeah, we'll do a timer and we'll see who wins the race. You know.
Is it bonus if we guess right, like on the paper?
No. It's a good option. Like, here's one thing that I really try and not do. I'll be honest. I'm really, nuts about ensuring that the deductions are fair, but I usually very rarely do bonus credit or anything like that because, as much work as I'm putting in, it's like the grade is what the grade is. But usually with this course and with this type of exam, like if you're giving it an honest effort, the grades aren't like, that's not the problem. So yeah. You're going with number 3?
Yeah, he's in the back at first, so obviously he has to win.
I can't stop watching it. I don't know.
I'll say this, I've had some students, I get mixed reactions on the classroom timer because sometimes students really like it because they know how much time they have, and then I have students that get really freaked out because they're like, So, no, I'm not doing the musical.
I'll watch the race.
Yeah. Man, I feel for the people who like are not in this class right now, and because I post the videos on YouTube, and so when I hit play, who's ever listening to this on their headphones, this recording, man, that's going to be bad. Somebody's out, listening to this in the gym in some college in Indiana, and they fall off the treadmill or something. I'm sorry. Like, comment, subscribe. All right. I'm just kidding.
You should get a cool, catchy phrase for the beginning of your videos.
You should have a cool
This video is sponsored by Skillshare.
Have someone make one of those cool intros in 2009 YouTube ads.
Oh my goodness. I turned comments off a while back. I had this one guy who I'm pretty sure was trolling me and had these really bizarre comments on every videos. It turned into a running joke in class because, yeah. So I turned those off. But any other questions? Yes.
Can you go over how to find which joint to solve for the moment equation on method of sections?
Oh, for the method of sections. Okay. I can. Do you want me to pull up the homework solution that is associated? Okay. That's a good question. So the question was looking at strategies for moment summation on method of sections. So here's the problem that we did. Okay. This was the homework problem, and let me zoom in a little bit to where we're not seeing that little arrow that tells us where to sum moments. So let's handle this problem a couple different ways. The first thing I want to do is I want to look at the truss in general and ask, is everybody okay with the construction of this free body diagram? Okay. In other words, I'm slicing through these 3 members, right? 3 members because it's the method of sections. And I mean, honestly, this problem said solve for this member, and this member, so it wasn't like we were going to cut the section any other way. But, okay, so here's the construction, here's the section, and I've got 1, 2, 3 members, and 2 of them are diagonals, right? Okay, with me so far? Now, let's see if we can identify the 3 locations about which we could sum moments, because there are 3. Okay, now, the first is I, right? And I could sum moments about point I. These 2 members would go through, and I would be left with CD. But if I'm being, an analyst in terms of using these three equations of equilibrium, I am left with two diagonals. Now, I could sum moments again, but it's not as efficient computationally. It's not as fast. But hold on. Okay. So I could sum moments again, but it's just not as fast and efficient than just summing moments once and then moving on. So while I theoretically could sum moments at I, it's going to leave me with two diagonals. And I'm going to have to break out the solver on the Casio FX115 ES Plus or whatever calculator you have, and I'm going to have to do that. I kind of don't want to. Okay? So the second option is to find where two other members coincide. So point I is where these two members meet. What about this member and that member? Where do those members meet? E. Could I sum moments at E? Yeah. No reason not to. In fact, summing moments at E is a viable solution strategy. I can sum moments at E. This member goes through. This member goes through. And as for this, what I would do is take this, slide it on down here. The horizontal component goes through, and I would just be solving for the vertical. So if I sum moments at E, I'd have 20 times 10, and then CIY times 20. And I think that CIY was, in fact, 10. Yeah, it was. And it was negative because go back to the free body diagram. Here's the free body diagram. If I have 20 times 10 and CIY times 20, well, that doesn't make sense. CIY would have to go in the opposite direction. So that would mean this assumption is incorrect. Does that make sense? And I would get the CIY term, if I got CIY, slope ratio for CIX, now I've got this diagonal. Some forces in the vertical to get that, slope ratio to get that, some forces in the x direction to get that. That is a viable solution strategy. Nothing wrong with that. I could have done that on this solution. I just didn't. Because what I did is, instead of figuring out where these two members meet, and instead of figuring out where these two members meet, I figured out where these two met. Where do these two meet? C. So I sum moments at C to get that member, sum verticals to get that member, horizontals to get that member. Does that make sense to everybody else? Now, did that answer your question? So theoretically, there's nothing wrong with summing moments at any of those three locations. In fact, if I'm being real particular, I could sum moments anywhere. I could sum moments at D. Now, what would happen if I summed moments at D? I would get a hot mess of alphabet soup at the end. But let's say I did that. Let's say I sum moments at D and I get a hot mess of algebra at the end. I could sum forces in the x direction and get another hot mess of algebra. Sum forces in the y direction and I'd get another hot mess of algebra. So I would get three hot messes, right? In other words, three equations, three unknowns. Take those three equations, three unknowns, plug them into my Casio FX115 ES Plus, use the 3x3 solver, and get the answers that way. That'll work too. Nothing says you can't do that. Just algebraically, it'll be a little bit of a mess. If you really want to test your understanding of structural analysis, do that and see if you get the right answer. Because again, that trust doesn't care how you do the math. It doesn't care. The answer is the answer. As long as you do the math correctly, it'll work out. That beam that's supporting this ceiling above us, it didn't care whether the engineer used Excel or MATLAB or, it doesn't care. It is gravity, you know. Yes, sir.
Onto like the virtual like work assignment or work like assignment of the equations, like a problem
Yeah.
on the test?
So that's a good question. So the question was, are we going to have a bunch of system of equation problems for truss deflections? Because then you'd have two truss analyses you'd have to solve. And the short answer to that is no, I'm going to try and avoid that. I'm not going to. One of the goals that I have whenever I make an exam, and it's a goal, and I'm going to go to that here in a second, but I don't like asking you the same question twice. In other words, once I test you on something, let's move on. Okay, it's time to look at something else. And so if I gave you a truss problem that had a 2x2 solution, and then gave you a truss deflection problem that also had a 2x2 solution, then I'm just making you do a bunch of extra work because I'm mean, you know. And my goal is to avoid that, okay? Now, that being said, I am not a micromanager, okay? And what I mean by that is I can't control, once you have the exam in front of you, how you choose to do the problem, right? And so if you choose, let's say this problem, if you choose to sum moments at I and then are left with two equations, two unknowns, there's nothing wrong with that. It just might not be the most efficient way to do it, okay? So what I'm getting at is I am trying to avoid overcomplicating the exam, but I can't prevent you from overcomplicating the exam. And so sometimes it's worth it on the problem to take a step back and go, am I doing this the best way? Like, for example, when we were doing our, our second truss problem, before we did anything, we said, what order are we going to do this in? We said we're going to solve joint A, then we're going to solve joint H, then we're going to solve joint D, then we're going to solve joint C, etc., right? We tracked that out before we even did any math. We just did it, strategized it in our head a little bit. And we did that problem at a much faster pace than we did the last one. Okay? There are ways of making this test easier on yourself.
So for method of section on the diagonal member, if you're doing moments at C, you don't have to like flip the x and y components where they're facing, or would that even matter in this situation?
You talking about this one?
Yeah, because
well, they're going through C. That member is going through C.
My brain says well, it's going back that way too, and they're in opposite directions, but I don't know if that would change anything.
Well, here's the thing. If you're summing moments at C, these components can slide up and down, right?
Yeah.
And so putting them there, the moment is 0. Okay, let me go back to some base statics, like base statics, okay? Remember, the fundamental definition of a moment was R cross F, right? So here's a point, here's a force, right? And that force acts along that line of action, right? R is a vector that goes from that point to that line of action. And if here's the line of action, it doesn't matter if it's here, 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 here. You get the same moment every time, right? Because the position vector, it goes from the point to the line of action, okay? So what I'm saying is if you're summing moments here due to this point, it doesn't matter whether this force is here, 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 here. Here, you're going to get the same moment. Here's a healthy example. We know what the answer to these forces are after this problem, right? We know that this is 10 going up and this is 20 to the right. Take those forces and put them here. 20 to the right, 20 times 5, 10 times 10. The moment contribution is 0. It doesn't matter if those forces are here or they're here. I'm saying slide them wherever you want to make the moment computation easier. That's what I'm saying. Does that make sense?
Yeah.
Everybody else okay with that? Breaking out that statics again. We'll break out a little more mechanics of deformable bodies later on when we look at beam deflections or mechanics of materials. I know you all love that class, right? I'm teaching that class next semester. 216.
Now you're
I can't go into. If I had a time traveling DeLorean, I wouldn't be a university professor.
What would you
But then how would we learn structural analysis?
If I had a time machine, I wouldn't care about your instructional. That's your problem. That's good.
What are you going to do? Then you're just going to have a time machine and a bunch of unstable buildings.
That's a fair point. I'll just, keep away. I don't
go back in
know.
time again?
I'm coming up with. I'm trying to come up with sarcastic remarks, but my coffee's wearing off, so I think.
Travels into the class and teaches it, and travels ahead teaching it right.
There you go. Temporal paradoxes. They're a lot of fun before a structural analysis exam. Okay, any questions? I'm feeling like we don't have any, and besides we got 2 minutes before the exam review ends, so I'm just going to go ahead and call it. You all have a lot of fun between now and Friday, because, well, you're going to have the celebration on Friday, so be prepared. That's all I got. We'll see you.